Hello, good evening everyone. I'm Lucas Copio, and today we're going to talk a little bit about ProxySQL. Let's say you have a managed database that is large and read-write heavy. It may do table locks, or you need to make so many connections from other service that you can't have a single giant database, either because it's too expensive or just don't need that much to run our CPU. What we really need is something that read selects from a replica database that has the least replica lag, which does fall back to another replica in case of a failure, and stops communicating with a lagging database for long enough so it has enough time to replicate, and stops communicating with a lagging database for long enough so it has enough time to replicate properly. First of all, ProxySQL was created to load configurations at runtime. Okay, so what it means is that it has 3 layers of persistence for the configuration. It can be either at the disk, or it can be in the memory, or it can be in the application or runtime layer. The ProxySQL is a service that runs like an SQL client, which you set up to see how it will receive connections and how it will pass those forward. Well, so let's set up a base configuration. Here it is. This is the Docker Compose that declares my service. Also a volume, so you can access the configuration files if needed for persistence. Since we are going to build a ProxySQL, those are the data that I'm going to use. So it's a mock credential for 3 replicas and 1 master database. There are 2 users here. One's the read-write user, and the second one is a monitor only user. So this monitor here, it's a monitor only. This is the read-write, and here we have the 4 databases. The MySQL proxy works well with just 1 replica and 1 master, but here I'm going for a more heavy environment, so we have many replicas and a master. So as I told you before, we have a base configuration. The communication port for the ProxySQL is 6033. It's exactly the opposite from the MySQL, that is 3306. The best configuration is when you have the ProxySQL as a sidecar for the service that you want to run and which will communicate with the database. This way you have an extra layer of security and avoids SPOF. You have your service connect to the local host in this specific port, and the ProxySQL communicates with the database. So you have a single point to configure the database and the ProxySQL itself. Also, if you need to change the database during runtime, you can change because the ProxySQL allows you to do that. Also, you will want to access the service inside the Docker for setup. So usually all you have to do is make a .sh file with the following commands. So let me show you here. You can just use the Docker Compose exec proxy MySQL -u admin, password admin, the host, the port, and then you prompt admin, and that's it, you're in. Let's run my Docker Compose. cd. So let's go. Docker Compose up -d to demonize the service. Scripting the network, ProxySQL default with the default driver, pulling proxy. It will download everything. It's going to be fine, which is awesome. We are going to set up the ProxySQL, set up all the servers that I have. Here, you remember, we have those servers here, the master database and 3 replicas. Well, it's already pulled. So if I do docker ps, you'll see that docker ProxySQL will be running. And if I go with this command, which I will have to write down, we will be inside. And I believe it won't work because I don't have the MySQL on my computer. The Zach failed. This is the great ProxySQL. So now we are going to start working properly in this stuff. First, let's understand how the persistence works and how to set up correctly and change the configuration and pass it to runtime. So as I said before, we have three positions where the changes that we do are stored. We can have the data be in three different places. It can either be on disk, memory, or runtime. Disk is where you want the data to be persisted. So you basically persist SQLite to disk. The memory is where all the changes you make to the configuration are stored. The memory is volatile. So if you have to restart the program, you will lose any change you've made there. And last, we have runtime. Runtime also is volatile. So if you do any changes to runtime and you restart the program, it will lose the changes you've made there. Basically, when you load the program, it loads all the configurations that are stored in disk into memory and from memory to runtime. Every time you want to change something, you change it in the memory. Then you decide what you want to do. If you are going to push it to runtime, if you're going to push it to disk, or you can override the memory with data from the disk or from runtime. In those tables, we have global variables, MySQL collections, MySQL query rules, application host group, server, and users. Those 6 tables, we can persist global variables, query rules, servers, and users. Okay, so those two, this one, and this one. Those are the tables that we can persist. To persist on anything to file, all you have to do is write down save, then you enter MySQL and the name of the table. So if you want to save the users, MySQL users to disk, and that's it. Now, if you have made any change to the users table, it is saved to disk. If you want to load from disk, load MySQL users from disk. And now we have loaded into memory everything from the disk that we had before. If you want to load from memory to runtime, so you want to propagate some kind of change we've done to runtime, you do load MySQL users to runtime. We don't have to stop the service, we don't have to restart the service, it simply is. Also, if you want to make changes from runtime to memory, you can do save MySQL users to memory. This is basically how we load and save data. It's very, very important that you save everything that you change after the configuration. Now we have the global variables. Well, let's see what we have here. Global variables. Oops, select from global variables. Okay, here we have all the global variables. Those variables are very important for us, but mainly the MySQL default char set. So we have here MySQL default char set. My database, my own personal database, uses Latin 1 instead of UTF-8 or some other kind of Unicode. So in my case, I will have to update for this char set. I'll do update global variables set. Latin 1 where variable name equals to MySQL default char set. Okay, it's updated. So if I do a select, I'll have here the Latin 1. And as I said before, we have to save every change that we do to disk so we don't lose it. So save MySQL variables to disk. Now we have to change the user's configuration. So select all from MySQL users. It's completely empty, which is just fine. So let's insert our first user. Insert into MySQL users, username, password. The values are root. The password is 4PJNSQKE. Host group is 10. Okay, inserted. So now we do a select all from MySQL users, and we have one single user. Perfect. So now let's talk a little bit. The user configuration is a table that you keep the user that has read and write access to the master database and usually also read access to the replica databases. You don't necessarily have to have a single user. So the host group is a way that we have to divide databases in groups. So you're going to have a group of replicas, a group of read-only, some maybe a special database for heavy loads, another one that's faster. Right now we are going to use just the host groups 10 for read and write database and the group 20 for read only. Okay, so we have added the first read and write user. Now we need to add the monitoring user. Since the replicas have a lag when compared with the master, it means that we need a special user that is capable of reading this replicas, this information about the replication lag. And unfortunately, it's not a MySQL user, at least not here, but it's a MySQL user in a global variable. From global variables, we will find someone with the name monitor. So MySQL monitor connection interval, pinging interval. We can change the ping from 10 seconds to 5 seconds. So we have a faster communication with the replicas. So which basically means every 10 seconds we monitor the replicas to see how lagging they are. We have here the MySQL monitor username and MySQL monitor password. Here they are both monitor. The ones that we have that are in this other table, as you can see, it's the monitor and the password is this hash. So we will go back and change this. So let's change at least, the name is right already, so we only need to change the password. So we do update global variables set variable value equals to ts8, where variable name equals to MySQL monitor password. Okay, it's up to date. Now again we save. Let's save MySQL users to disk because we have a new user, and let's save MySQL variables to disk because we just changed the monitor. Okay, the monitor is a user that needs special permissions. Okay, you will find in the Oracle documentation how to set up the perfect monitor user. Unfortunately, it doesn't work. Okay, let me show here how it should be done. So we have here the suggested permission for a proper monitor. The thing is, it doesn't work if you're using a managed database, which is probably the case since setting up replica database is not the easiest thing in the world, and managing them and having a good backup is also very hard. So it's usually quite cheap to have a database outside. What you will actually need is select application client, show databases, and process. The only change from this one to this other one is, of course, here it says localhost, here is a wildcard, and you don't have the super permission here. Only process, databases, application client, and select. Unfortunately, the super is usually out of your reach when you have the database like a AWS RDS. So let's go back here. We have already saved the variables to disk. We have saved the users to disk. Now it's time to set up the databases, the real deal here. One nice thing is that each database you may declare how much application lag is acceptable. MySQL servers. There's no describe. Okay, so let's just accept it. Let's start to add the databases. Let's start with a master here. Insert into MySQL servers, host group ID, host name, max application lag, and those are the data. Host group, as I said before, is the group that will separate each group of databases. So I defined that group 10 is master only, group 20 is everyone including master. Okay, I said before that group 20 would be replicas, but you see, it doesn't really matter. You can enter the same database 2 times, 3 times. It still works, okay? So let's add the values here. So first database is just the master. So master database dot placeholder dot xx somewhere -1 dot rds dot amazon aws.com max replica 5 doesn't matter because this one is the master. Of course, I wrote replication. Now it's right. Okay, so I just added the max replication lag. And let's add the next ones. So the next one is going to be group 20. This group, I could call it group 12 or group 1. Doesn't matter, just the value that I decide here. Search into MySQL servers host group ID, host name, max replication lag values. So now I'm going to add all the databases. So first is the master. Okay, we have the database and the 3 replicas inside the memory. So if I do a select all from MySQL servers, we're going to see here the master database in the host group 10. In the host group 20, we have the master and replicas 1, 2, and 3. Here we can see a few extra information that we have, so things like the port that is using to communicate, the status of the database, so it shows here it's online, the way is very important because it says, well, it's the weight of the database. So if a database has weight 2, it means it will receive 2 times more connections than those that has the number 1. There's also things like use SSL, the latents, and you could add some comment here. I just keep it simple. No SSL right now. You should use no latency in milliseconds because it's everything in the same data warehouse. So it's quite. I need also to persist those to disk. So save MySQL servers to disk. We have now the variables that will set the monitor. We have the user. We have the monitor user. We have the databases already here. So what's missing? Well, it's missing the query rules configuration. Query rules are simple. You may either enter a digest of a query, which is kind of a hash, and tell which host group it may send the query, or you may enter a matching digest, which is a regex, or the prepared statement. And then you say which host group may receive the query with the matching pattern. The documentation of the ProxySQL is quite interesting and has a few some data regarding those queries that you're going to do. You could do. So one of the main rules you do is this one: insert to MySQL query rules active to say that this rule is actually active. Match digest. Here we are going to add the regex. Multiplex. I don't really know what it means. Destination host group. And apply. And usually we go with those. The first, yes, it's active, and then it is a select. It starts as a select and has something. And that's all. So I add the multiplex, I add the destination group, so this one is going only for the host group 20. And I add the apply here, so 221. I also going to add another query rule here, which is another select. This one is just a select, so it's very, very open. Anything that starts with select has to go to host group 20 also. And table multiplex. It has no multiplex. Okay, remove it. Select all from MySQL query rules. Well, probably the multiplex got removed. Yeah, just so documentation. Ignore the multiplex stuff. So now we have the match digest here and here. We could add some things like cache TTL and number of retries and delay, if it is to be applied or not, if there's a mirror host group that we should put. Well, there's a lot of stuff here. You could add a username that is only that username is going to use that query, so you can do some weird stuff with it. But this is basically the query roles. It's very important that you understand that all queries that go through the ProxySQL, if they get matched by the query rules will be applied over them. So otherwise, it will just distribute the connections and the queries in between the databases. So the query rules are very important to make your life better, okay? After changing the rules, let's save it to the disk. Save MySQL query rules to disk. Save it. Okay. Save MySQL servers to disk. Okay. We have the user saved to disk, the query rules saved to disk, the variables saved to disk, and the servers, which means that we are ready to start working. So first thing we have to do is to load to runtime all those things. So we start load MySQL users to runtime. Load MySQL variables to runtime. Load MySQL servers to runtime. Load MySQL query roles to runtime. And now everything is loaded to runtime. I suggest that you go to the ProxySQL GitHub. They have a really good wiki page with specifically this article, read and write split, how to, which explains to you every single bit that you need to do to start a very complex query role. Usually after changing the global variables, you need to restart the ProxySQL. You can do it from inside here, just writing, and there it is. The MySQL has gone away. And here again, so as you can see, the ProxySQL restart does work to restart the server. Well, now you need to learn how to manage the database. Some things you have to learn, like how to stop databases and how to take replicas from the round robin, so you can do maintenance or maybe do an update or maybe remove a database that has stopped replicating. To do those kind of stuff, you have to disable the database first. One way to do it is with this query, which you make an update that sets the status of the server as offline, and you tell which is the host name. You have to do it in the MySQL servers. Then after you've updated as offline soft, you have to propagate it to runtime. Okay, so you will go update MySQL servers set status equals to offline soft, where hostname equals replica, so replica 01 placeholder.xx somewhere -1 .rdf Amazon and AWS.com. Okay, now the replica 01 is set to soft offline, which means it will stop receiving connections until it is completely out of connections. But first you need to save MySQL servers to runtime. Oh, sorry. Load MySQL servers to runtime, which will send the changes that we have done in memory to runtime, and which will start to gracefully disable the database. Instead of offline soft, you could change it to offline hard. The offline hard will kill connections that are already communicating with the database, so usually it's better not to, okay? And if you want to set up the database back to online, all you have to do is set it to online. And it's working. So it's back online. There's also a third way you can do for removing a database. You can simply delete it. Internally, the backend will set it to offline hard and handle it in the same way. But usually the best way is to use offline soft. Okay. There are a few things that you need to learn to troubleshoot. There are a few things that you have to learn for troubleshooting. The first one is flush hosts. Flush hosts is very important because if by any means you decide that it's a very good idea to put offline a database or have a database receive more connections that the ProxySQL can handle, this means that you have many errors. And if you have too many errors, you will start to have bad communication with the database. And to solve this problem, you need to connect to this database and manually flush hosts. And by flush hosts, I mean you connect in that database, okay? May it be a replica database or a master database, doesn't matter. but you need to connect to this database and write flush hosts and then push enter. This will remove all the bad connections that ProxySQL has with that database, allowing it to communicate fine again. There is also a last bit of information that you need. Usually you can have replicas that are of different sizes, so they are different EC2 instances. I suggest that you do not do that. So if you're using T2 large or T2 small, keep every replica the same size. If you really want to change the size of one particular instance, I suggest that you start to really tinker with the number of max connections and with the weight that you define for the server. But I suggest against using different instances for your servers. Okay, it's much more headache than it's worth. And if by any means you need to change the instance during runtime, please set offline soft first. Okay, do not make the mistake of making a hot swap of the instance during runtime with that database active in the host group. If you do it, your system, your ProxySQL can crash or simply stop responding, and in some situations will stop reading data from the master. In other situations it will take from half an hour to 1 or 2 hours to get back to normal. Goodbye and fly safe.